Hi there! Welcome to this video in which we are going to talk about binary operations in Golang. This is my first video in English, however, I will do my best. Alright, welcome again and let's get started. Through this functionality, we can perform operations with binary numbers. For instance, we can define a variable a to represent a binary number, another variable b, and employ logical operators to execute operations that yield result x. We use logical operators to compare two values. They allow us to combine two values and obtain a result of either 1 or 0. There are three common operators, and, or, and not. In our examples, we will use variable a and b as input and variable x as the output. In the operation and, when a and b are both 1, x is 1, otherwise x is 0. In the operation OR, when a or b is 1, x is 1. The only case where x can be 0 is when a and b are both 0. And the last operator in the image, not, unlike the other logical operators, not only take one input value. And the value of x will always be the opposite of a. For instance, if a is 1, x will be 0. And if a is 0, x will be 1. And, or, and not are the most common. However, there are other logical operators that we can see in the image. In the image, we have and or again, but we can also see the other logical operators. The first is XOR. XOR is equal to OR, however, with a difference. If a and b are both 1, x will be 0. X is 1 when a and b aren't both the same value. For example, if a and b are both 1, x will be 0. If a and b are both 0, x will be 0. Otherwise, x will be 1. Alright, we have NAND. NAND is the opposite of AND, is AND plus NOT. X will be 0 when a and b are both 1. Otherwise, x will be 1. Okay, NOR follows the same logic as NAND, but of course, with OR. NOR is the opposite of OR, is OR plus NOT. If a and b are both 0, x will be 1. Otherwise, x will be 0. And finally, we have XNOR, which follows the same logic as NAND and NOR, but of course with XOR. XNOR is the opposite of XOR, is XOR plus NOT. X will be 1 when a and b are both the same value. Alright, these concepts are about logical operators in general. And now we are going to see this stuff in Golang. Here we go. Great, I am going to create a 16-bit positive integer variable with the value, let's say 213, for example. And I'm going to print the value using %b. And we can see the number 213 and its binary representation. Alright, these operations are left shift and right shift. We can use them to shift binary values by n positions. Okay, let's do some examples. In this case, we can shift it 1 to the left. And in this case, we shift it 10 times to the left. Okay, if we shift this value 10 times, the value will be, for instance, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This. However, the result is 1, 0, 1, 0, 1, and many zeros. The value is truncated. This happens because the value being shifted is bigger than 16 bits. Okay, this is the other operations right shift. In this case, we shift it once. Of course, the number will be decreasing. In this case, we shift it 10 times, and in the other case, we shift it 5 times. I clear the console and go run main. Alright, I run the program and we can see the values. Notice something. When we try to shift it 10 times, the value was 0. There will come a point where we won't be able to decrement it anymore. And it always be 0. For example, in this case. It makes sense because the original value has 8 digits. Right, we are going to see logical operators in Golang, declaring another variable to perform the following examples. Okay. We will use a 10-digit format to fill it with leading zeros. I run the program, clear, and go run main, and we can see the result. Sorry. Here. Perfect. If we want to perform an AND operation, we use the ampersand character, just one, as seen in this case. For example, between A and B. If we want to perform an OR operation, in this case, we use the pipe character, this one. If we want to perform an XOR operation, we can use the correct character between both. For example, in this case. On the other hand, we use the correct character to perform the NOT operation by placing it in front of the variable. For example, in this case. I run the program, go run main, and we can see the result. Sorry, I need to save the program. Save as, and go run the program again. Sorry, my mistake. FMT package. Clear, go run main, and we can see the result. Okay, we can see the result for each operation in decimal and binary representation. Yeah. In the case of NOT, a large binary number is seen compared to the previous one. This is because for the previous cases, we had leading zeros that didn't represent anything. But when perform a NOT operation, those zeros are converted to 1, that now represent values. It will fill with ones up to the capacity of the variable, in this case 16 bits. Alright. To use the NAND, NOR and XNOR operation, we do the same as in the previous example, but add a NOT to each one. For example, if we want to perform a NAND operation, we take the NOT of an AND operation. For example, in this case. And the other are the same. We take the NOT of an OR operation, and in this other case, we take the NOT of an XOR operation. Alright, I execute the program, go run main, and we can see the result. Sorry, I need to save the program. Okay. Go run main again, and we can see the results. Here. Great, perfect. We are going to perform a small example using rules. We will have the rules read, write, update, and delete, each of which will be represented by binary numbers with only a 1 in different positions. For instance, read roll 0001, write roll 0010, the update roll 0100, and finally delete roll 1000. Alright, we are going to do it this way so that we can perform a sum and based on a number. The sum of the rules we want to assign to a profile. We can identify which roles the profile has assigned. Those 4 variables that will represent the roles. Okay, then we are going to assign the roles to a profile, we will add the rules for writing, reading, and deleting, for instance, in this case. Yeah. Great. And now we validate if the profile has permissions to perform an operation using the bitways AND operation. I am going to run go fmt. Okay, perfect. In this case, if the result of the AND operations equals the rule, it has permissions. Otherwise, if the result of the AND operation is 0, it does not have permissions. For example, in this case with the read role, I run the program, go run main, and we can see the result is yes. Yes, the user has permissions. Okay, for instance, when we validate our profile with the rule update rules, update and I run the program, go run main, and we can see in this case, for example, we find that the profile doesn't have permission. And on the other hand, if we validate it with, let's say, delete role, I save the program, clear, and I execute go run main, we can see that the profile has permissions again. Great. We have seen binary operations and how we can use them in Golang. This functionality is very interesting and useful for perform operation at the bit level. Excellent. I greet you and see you in the next video.